Hey everybody, so today I'm going to talk to you about my crystal radio set. Here we see a simple schematic of a basic crystal radio. So crystal radios pick up AM frequencies, that's in the 500 to 1600 kilohertz range. We can see from the schematic we just have a basic antenna, an inductor and capacitor in parallel hooked up to ground, running through a diode into our headphones or output. Typically for these sets we use a variable capacitor so that we can tune into different frequencies. With something like this you're only going to get probably one station. So a variable capacitor looks something like this guy right here, where we just have metal plates that we can spin around to vary the capacitance. Obviously a higher capacitance when the plates are together but not touching. Okay, so we see that the AM frequency, we know what range it's in, and we can calculate what kind of inductance and capacitance we need to tune into these stations. So I started off looking at the middlemost station, like 1050 kilohertz, and calculated that to do this I could use an inductor that's about 150 nanohenries and a variable capacitor from 65 to 670 nanofarads. This variable capacitor goes from about 0 to 40 picofarads. And it turns out that this range, in the nanofarad range for capacitance, is just far too large. In order to get that capacitance, we would need just an absolutely huge array of capacitors like these. And that's due to the breakdown voltage in air. So you're really kind of limited there. What is available, it tends to be variable capacitors in the 4 to 400 picofarad range. You can put these in parallel to get greater capacitance. But I just picked up one. So with this variable capacitor, we need a coil with 250 microhenries. And that's a very typical setup. Often people will use a couple of these variable capacitors and typically a pair or one of those inductors. So this is our simple circuit. I have an example of this setup right here. So this is a basic crystal radio set. It's just a wire wound around as a coil with a diode hooked up and a ground and antenna connection. This was like 13 bucks and you have to hand wind the coil. But unfortunately it doesn't work too well. It didn't work at all with my piezoelectric earpiece. So I ended up hooking it up to a simple amplifier that we'll talk more about later. But with this set, we can see when I hold it, I pick up one station. That station is KFI AM 640. It's like an LA Orange County station that is a 50 kilowatt tower. Typically these stations have a range of about 40 miles. However, when it's night, the radio waves will bounce off the ionosphere, and that allows you to hear signals from all over the world. With a simple set like this, you're not going to get that. You're really just stuck with your one station, no matter where you tune the radio to. How do radio waves work? Why does this happen? So the inductor and capacitor are in parallel, so they have a resonant frequency. So the antenna is going to pick up a bunch of frequencies, and these guys kind of tune your circuit into that specific frequency. When we send these signals, so this is our frequency, right, 500 kilohertz or 1600 kilohertz, and we interlace it with our sound. And so basically we get to hear the sound due to the interlacing of the high frequency which is being transmitted at and the original sampling of the song. However, we need to get rid of, since it's a sine wave and we have positive and negative, if we played this through a speaker we'd hear nothing. So we have to cut off half that line, or the top half or the bottom half, it doesn't matter, which is what we see down here. And that's really the purpose of that diode right there. Okay, so we saw our super basic set running through a couple op amps. So this is the next step up. This was also 13 bucks. And it's just a basic AM radio. This guy doesn't need ground because it has a ferrite rod in it. And so we can see it's just got the inductor, antenna, going to an amplifier, to the detector, and then to an audio amplifier. You can see a nice circuit of it right there. Schematic. So let's see how this guy does. This is just using a single 9-volt battery.
011-0897 NMLS 1978. Scott Brownsbaum, played by Scott Brownsbaum. You want to go solar? Your electric.
So when we go down, we just get noise.
Solar with Semper Solaris. We've saved new customers up to $3,000 and are still the only solar company that gives you the equivalent of a California rebate. We install panels made by SunPower, an American company.
But it does pick up a few other stations, and especially depending on the orientation. Well, that's enough. Okay, so those were the ones I was kind of comparing my stuff to. I was hoping to get more than one station. This guy seemed to pick up 2, maybe 3 or 4, depending on the day and the time. Okay, so this is my radio. As we can see from the circuit diagram, it's not too complex. We just have an antenna. We've got our 250 microhenry inductor, our 365 picofarad variable capacitor, and then I've got it hooked up to a simple amplification circuit powered by 2 9-volt batteries. Back here we just have the connections to the antenna, which is purple, the speaker, which is blue, and the ground, which is black. We can see a detailed view of the amplification circuit here. I just used 3 411 op amps with a predicted gain of about 1300, but an actual gain of about 290. We can see I just used a pretty simple circuit there. To power these guys, I've got a little schematic of the power as well. So let's see how this guy does. I've just got to plug in the speaker. Plus, this is the KFI AM640. And this is KNX 1070. It's also an LA station. So not too bad. I get 2 stations pretty well in here. This is ideally you'd want to use about a 100-foot antenna. Right now I'm just using about 25 feet of cable. So I would get much better reception with an actual antenna run outside, not in this bricked-in lab that is surrounded by concrete and lots of interference. So not bad. 2 stations. Alright guys, that's about it. Thanks for tuning in, and I hope you learned about AM radios.